Hello guys, it's me Isaac, and today we are going to talk about inference in regression. And before I explain the stuffs in the week 13, I want to recap a little bit about the t-test. Okay, so I'm gonna revisit t-test. So let me start with the basic thing. T-test and maybe CI for mean, confidence interval for population mean, and if you remember what we have learned in the constructing the confidence interval, we divide the case into the two cases. One, we want a case where we already know what is the population standard deviation, but another case is that we don't know, unknown. So we have unknown sigma, which is the population standard deviation. So I'm gonna quickly recap these two. Okay, so first, we know that some random variable follows the normal distribution whose mean is population mean mu and standard deviation is sigma. And from the sampling distribution class, what we have learned is that if x follows the normal distribution, then x bar follows also the same distribution, which is the normal distribution, and it will have the same mean, which is the population mean mu, but has the different standard deviation, which is sigma, which is the population standard deviation over square root of n, and this is sample size. This n means sample size. So what I want you to focus here is that when we have this form, something follows the normal distribution, and we know that the mu, and then we don't know the we want to construct the confidence interval for population mu, so this one, but we don't know what is the standard deviation for the population, so population standard deviation sigma. In that case, what we have done is that first we replaced sigma with sample standard deviation. Okay, and then second, construct the CI with the x bar. So this x bar plus minus and t critical value, which is n minus 1, and maybe if we want to construct a 95, then I set up my alpha as a 0.05, which is the number that can make the 1 minus alpha makes the 0.95. Okay, and then what we did is we write down this part in here. So sigma, not sigma actually, s over square root of n. Okay, so originally maybe here sigma, we need to put sigma here, but since we don't know what is the sigma, we replace that sigma with the s. So s over square root of n, we call this term as standard error. Okay, so this is what we have learned for the CI. So to construct the CI, we use this x bar and then plus minus critical value from t distribution, and then we just write it down, this the term in here. So whenever we know that something follows the normal distribution, and if that's mean is the population mean, or maybe population mean, and then if we know the standard deviation, then we can construct the confidence interval using this term and its standard deviation. Okay. And for t-test, our null hypothesis is like this. We want to test our population mu is this some specific number mu 0, and maybe our alternative hypothesis is like mu is not mu 0. Okay? And in this case, what we had to do is that we want to calculate the t-test statistic. Like this. T is x bar minus mu 0, and here is also sigma over square root of n, but we don't know the sigma, so we replace the sigma here with the s. So what is the common thing in constructing the confidence interval case and the t-test case is that we use this one and this term again. Okay, so we put this one in here, and then we put this in here. Okay. So if you remember this, and then if you keep thinking about this thing in the t-test and the confidence interval, you're gonna find the similar thing happens in inference in the regression setting. Okay. So in the regression setting, we want to find the regression line, which can be written as this one, but we don't know, we cannot observe this line directly because we have some noise, and this noise, we assume that this follows the normal distribution, and whose standard deviation is sigma, and we don't know the sigma, so this is unknown. And so since we don't know the what is A and B, which means that we don't know the regression line, we had to estimate that A and B using the data set. Okay, so what we have done is that we estimate the slope first to calculate the by calculating the R and the SY and SX. So R represent the correlation coefficient, and SY represent the sample standard deviation for Y, and SX represent the sample standard deviation for X. Okay, so if we calculating these three, and if you're using this formula, we can estimate the B hat. Okay, and then after we estimate the B hat, A hat can be also estimated by calculating the sample mean for Y and subtract that from the B hat, multiply by X hat. Okay, so these two are the thing that we have learned from the previous regression class. Okay, and statistician figured out like this. This A hat also follows the normal distribution, whose mean is A, and then standard deviation looks like this: n plus x bar square xi minus x bar square. Okay, and B hat also follows the normal distribution, and whose mean is B, which is a true regression line slope, and its standard deviation is sigma over square root of summation xi minus x bar square. Okay, so these you don't need to memorize. So this is the just fact. So you can just understand what's going on. Like, statisticians figured out these two distributions, so we know we just take it as granted. Like B hat follows the normal distribution, and then its mean is actually true slope, and whose standard deviation is sigma over square root of summation of the xi minus x bar squared. Okay, how do we use this fact to construct the CI? Okay, since this B hat follows the this distribution, you can use this one and this one to construct the CI. Okay, however, we don't know what is sigma, right? So we don't know this one. So first, we want to replace the sigma with some s. Okay, and in our class, she just gave you, our professor gave you the formula how to replace the sigma with the data set, and she used the notation like this, and the formula for this one is square root of 1 over n minus 2 and sigma yi minus y hat, like this. So this is the residual, if you can, residual sum of square. So more accurately, maybe I would say this is residual, and then they just squared, and then sum them up, and then divide by n minus 2. And why do we divide by n minus 2? Because we estimate the A and B, which is our parameter. So for now, there's another reason, but for now you can just understand we have n observation, but we use the 2 to estimate the parameter number. So these 2 means the number of parameter we used. So in this case, A and B are our parameter. Okay. So we're gonna use this sy given x for as a value or as a replacement for the sigma. So our CI, maybe 95%, CI will be B hat, CI for B looks like this: B hat plus minus t distribution, critical value for t distribution, and whose degree of freedom is n minus 2, and then my alpha is 0.05. Since I want to construct the 95% CI, and then what I'm gonna do, I wanna put this thing in here with the replacement for sigma. So S y given x will be the replacement, and then square root of sigma xi minus x bar squared, and then take the square root of that. So this is the 95% CI for the regression line slope. Okay, and also we can do the t-test for B, which is slope. So in this case, what is our null hypothesis? Our null hypothesis is B is 0. And what does that mean? When the B is 0, what things can happen? So when you think about the regression line, we can write down its formula like this, right? Y is equal to a plus b x. However, when the b is 0, then x term, so when the slope is 0, then y does not relate it to x, right? So this means that when the b is 0, we can say that y and x does not have linear relationship. Okay, so this is our null hypothesis. So we want to test whether x and y variable does not have a linear relationship or not. Okay, so versus the natural alternative hypothesis for this should be b is not 0, which means that slope is not 0. Okay, and to test this, what we did in the t-test actually, first we want to calculate the t-test statistic, right? And this t-test statistic was x bar minus mu 0 and SE, but in this case now we already know what is, so t-test statistic is b hat, right? So we put x bar, since x bar follows the normal distribution mu sigma root of square root of n. Now we want to put b hat here because b hat follows the normal distribution whose mean is actually our true slope. Okay, so that's why we want to put a b hat in here. And what is mu 0 here? We want to test whether it is 0 or not, so we want to put 0 in this this place. Okay, and then for SE standard error, we already know that this one is like this. We already know this standard error is this. I'm gonna copy that. Like this. Okay, so since we have 0 here, I can just erase it. So this is my t-test statistic. And I know this will follows the t-distribution and whose degree of freedom is n-2. Okay? So if my t-test statistic is larger than the critical value, which corresponding to the our significance level alpha, which is maybe 0.05, then we can reject the null hypothesis. And also a p-value, you can calculate the p-value using the t-distribution, but since in our course we're going to use the SAS to calculate the p-value, okay? But usually in SAS will give you this form. So p-value, I would say p-value is the 2 multiplied by probability of t minus 2 is larger than t, and then you're gonna see this sentence in SAS. So whenever you see this statement in SAS, you can say you should recognize that, oh, that tells you what is the p-value is. Okay, so let's just move on to the SAS section. So we are going to use OECD data. We already used this data before, and so OECD dataset has a couple of countries information about PCGDP and the PCP and the number of beds. Like bed variable, for example, beds variable has the inpatient hospital beds for 1,000 population, and dataset made in 1996. Okay? So let me just copy this and paste into our SAS system to load the data. And you guys already studied this code before, so I'm gonna just briefly explain the code meaning. So we grab the URL to OEC variable, and then I declared my dataset name as OECD, and SAS, we ask SAS to grab this URL to pull the data from that URL, and we let the SAS know there are some variables, and our first column is country variable, which is character value because I put the $sign there, and then 13 means that I want to grab the 13 characters for this country variable, and my second variable will be the PCGDP, and third variable will be PCH, and so on. Okay? So if we submit this code, and then we can check the data using the proc print. So let me just type that proc print data is equal to OECD and run. Then we can check that there are 29 countries, right? And then first column, second column, third, fourth, fifth, sixth column will be there, and now I want to draw the plot first because we are gonna do the inference in that regression setting. So let me just draw the plot first. Okay, and I choose the two variable, which is PCH and the PCGDP, but you guys can also try other variables too. Okay. Sorry, my dog is barking. Okay, so I'm gonna use the SG scatter procedure, and I set my OECD data for the scatter plot, and I set the title like scatter plot of PCH and the PCGDP, and it's going to draw the plot using PCH and the PCGDP. And I put the two options. One is data label. So this data label is equal to country, meaning that SAS will use the information about the country variable, so this first column, to label the data point. Okay, so and then this regression equal to no group means that it will just do the regression using the whole data, and then it will draw the regression line. And this grid means our result plot has some grid, like horizontal and vertical lines in the plot. Okay, so let's just submit that. And if we see the plot, I got this. So it has a grid, right? And then it has a regression line, and all the data points has a label, which is the country's name. Okay, so since we have this result, let me pull up some question. So we are going to answer for these 7 questions. First one is the check the assumptions needed for regression, linear regression by examining the scatter plot. So how can we check the assumption? What was our assumption for the regression, linear regression? Our assumption was that we observe the data from the regression line with the noise, and we assuming that noise follows a normal distribution whose mean is 0 and the standard deviation is sigma. Okay, which mean what does that mean? That means no matter what x values, so no matter what in our case, no matter what PCGDP, when we pick some reason corresponding to that x, it should have same standard deviation. So the y value, so variation from the y value, for example, if I pick the around 15,000, the vertical variation of the data should be equals to other regions. So for example, if I compare it to this 15,000 area and then 25,000 area, it should be vertical variation should be similar to each other. And in my point of view, all the data kind of distributed like some band. So I can just let me just pull up. So we assuming that the no matter what we pick the x values, the vertical variation should be the same. Okay, it should be centered at the regression line and has this similar, I mean theoretically same standard deviation. So how can you check that? If we draw the scatter plot, and then if we found that the trends of the data, like they are distributed centered at the regression line, I can say, oh, the assumption for the regression line is satisfied. Okay, so when we compare this pattern and our result scatter plot, it is similar except few data points, such as United States. So if I think that United States is our outlier, then whole data set centered at the regression line, and it looks like the vertical variation does not varies that much, so I can say that our assumption is satisfied. Okay. Now let me do some regression inference in SAS. Okay. So in regression regression inference, we can do this only 3 code. So we can use this one and submit that in SAS. This will give you tons of data, tons of result. Okay, so if you submit this one, so I use the PCH as my dependent variable, and I set the PCGDP as my independent variable, and CLB, this option will give you the confidence interval for the regression slope and the intercept, which is A and B, true A and B. Okay, so let me check the result. Okay. Let me just I want to see the result in HTML, so let me just choose that option and resubmit it. So if I resubmit that, they will give you more nicer, prettier result. Okay. So we have a lot of result in here related to the regression lines. Okay. First, so they use the 29 data, and then we have this analysis of variance table, and also table for the parameter estimate, and we have a bunch of scatter plot and residual plot. Okay, and as we can see, they just also give you some band, right? And we can see that all of these data distributed around some band, except that the United States. So I'd say, oh, the assumptions for the regression line is satisfied. Okay, so let me just pull up some question that I have today. So second one is that the second question is that how well does the regression line fit the data? How can we confirm this? How can we say about the fitness of the regression line? Which measure should we use? The answer is R-square value. So in the result screen, we have this table. Okay, in that we have this R-square, which is 0.7642, and this R-square tells you that the regression line can capture the 76% of the variation of the data by can be that percent. 76% of the variation of the data can be explained by linear regression line. So in that sense, R-square will give you the answer for the second question. Okay? And third question is, the null hypothesis is that there's no linear relationship between PCH and PCGDP. Write this null and the alternative hypothesis as statement about population parameter. So what is the null hypothesis and the alternative hypothesis for question 3? So for question 3, so Q3 null hypothesis will be slope is 0 versus null hypothesis is slope is not 0, because we know that when the slope is 0, there's no linear relationship between x and y variable. So we can say that when the slope is 0, there's no linear relationship between x and y variable. In our case, we have piece h is our y variable, and GDP is our x variable. So null hypothesis should be the slope is 0, and alternative is slope is not 0. And what is the result of this test? So let me just go back to the question. So we finished to write the null and alternative hypothesis, and Q4 asks you to write down the point estimate and a 95 confidence interval for the parameter of interest in the hypothesis. So what is the parameter of interest in question 3? Question 3's parameter should be slope, right? And this is the coefficient of the PCGDP variable in SAS screen. So if I pull up the SAS, there is this table. So it will show you the result of the parameter estimate, and first term is the intercept, which is A, our case, right? We used A for intercept and B for slope. So this is the intercept, and then this one is the estimate of the slope, which is the estimate of the parameter. So this is B hat, okay? And if we look at the table, column names, this one will give you the standard error, which is SE, right? And then T value, which is T test statistic, and this is P value, right? Do you remember? Like when I explain the P value, I will give you the similar form. Like the P value should be 2 times of probability of T distribution is larger than the absolute value of T, and this is it. Okay, and then this part will give you the 95 confidence interval. So answer for the question 4, estimate and the 95 confidence interval for parameter, which is a slope parameter, then we can use this one. This is the estimate, and the 95 confidence interval will be this one, okay? From 0.07 to 0.11. Okay, so based on this result, the follow-up question is this. Number 5, based on your answer to the preceding question, would you reject the null hypothesis at significance level alpha is equal to 0.05? Yes or no? So let me just go back to this question. So question 4, we set the null hypothesis and the alternative hypothesis. And question 4, we observe the CI 95% CI for slope, and it says that what was the value? 0.07558 and the 0.11805. So this was the CI for the slope, and the confidence level was 95%. Okay, and Q5, if our alpha is 0.5, would you reject the null hypothesis? And the answer is yes. Why? Because this CI, 95% CI, does not include 0. So since the 95 CI does not include a 0, that means our p-value is actually less than 0.05. So we can reject the null hypothesis, which means we can say that, oh, there is a linear relationship between the PCH and the PCGDP. Okay. And for question 6, what are the numeric value of test statistic and the p-value for two-side test of no linear relationship between PCH and the PCGDP? This one is also ask you about the same thing, which is testing for the slope parameter. And if I pull up the screen, this will give you the same table. Gives you the same t-value, which is t-test statistic, which is 9.36, and corresponding p-value is actually 2 times of this one, but it says that this itself is less than 0.0001, so even if we double it up, it does not it is less than 0.05, so we're going to do the same thing. We can reject. So we can reject. So question 7, based on your answer, when we set the significance level alpha is equal to 0.05, we can reject the null hypothesis. So even if we, no matter what method you're going to use, for example, if you're using the CI for the testing the parameter, you're gonna reject the null hypothesis. And also, if you're using the t-test statistic, also you can we get the same conclusion of rejecting the null hypothesis, because our p-value is less than our significance level alpha 0.05, right? Okay. So I think I'm done for today. Hope you guys enjoy the weekend, and if you have any question about our discussion section and the lecture, you can send me an email. Okay, bye.